Hi folks, Mr. Long here. This is the second part of a video. In the first part, we learned to solve equations related to speed. In the second part of this, we're going to look at maximum minimums. And a typical question for multiple choice, for example, would be, how many local maximum values does s of x have in the first 5 seconds? Well, what's true, if s of x has a maximum, if s has a max, then we know that v equals 0, right? Or the first derivative is 0, right? V equals 0. But we know that v changes from, if it's a maximum, it increases and then decreases. So v changes from positive to 0 to negative. Okay, so that's what velocity does. It will change from, or the first derivative. So if the original function has a maximum, the first derivative changes from increasing, which is positive, to 0, horizontal tangent, to negative. Okay, so v equals 0, and then we have the pattern in velocity changing, or first derivative. How can we do that? Well, we already plotted our functions, or recorded our functions rather, in the table. And I've got 3 functions here. The original function, which is position, y2, which is velocity, and y3, which is speed. So we need to work with v of t. Well, that's in y2. So what we need to do is we need to see how many times does v of t change from positive to 0 to negative. Okay, so I'm looking for a sign change from positive to negative in the first 5 seconds. So again, I can do second function and table. And I'm going to do the first 5 seconds. And I need to be looking at y2. y1 is position. y2 is velocity. So I'm looking for a velocity change from positive to negative. So if I'm looking all in these these points now, this is showing me the velocity. So it's always positive up to 0.5 seconds. So positive, positive, positive. Oh, it's decreasing now. Notice it's decreasing, it's decreasing, it's decreasing, but it's like it's getting a lower value, but it's still positive. So the velocity is still positive. It's still moving to the right. Then all of a sudden, look at that. Between 1.1 and 1.2, it changes direction. So that's once. So one time. Because all the question says is how many local maximums. So there's a local maximum. Positive, the derivative goes from positive to negative. Let's see if it happens again. Negative, 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 negative. And I keep going. That's negative to positive. That means it hit a minimum. Okay, the velocity is negative here, then it's positive. So it did change sign, but it went from negative to positive. That's a minimum. But I'm only at 3.4 seconds. Now I'm looking at it again to go from positive to negative. Look at that. Doesn't look like it did it again. It only did it once. I'm going to go through this again. That's negative to positive. So that's decreasing to increasing. That's a minimum. And then I go up to here. And it went from positive to negative. So it just occurred once. It occurred at approximately, because it doesn't say at what time, but it occurred at approximately 1.15 seconds. 1.1 is 0.04. 1.2 is negative 1.79. So it might even be, it's closer to 1.1 than 1.2. So maybe 1.12. So once at 1.12 seconds. Okay, so that's one. It only has one local maximum in the first 5 seconds. Hopefully these 2 screencasts really helped.